So we can find, oh, hi everyone. Thanks so much for showing up for your learning. It is Mr. Jennings, your humble math servant, and we are looking at finding the roots of quadratic functions. This is a quadratic function, and we can solve it by factoring. Who's got it? If f of x is equal to x squared minus 8x plus 15, I seem to remember we can win an x game here. What are my magic numbers? Yeah, so what magic numbers multiply to positive 15, add to negative 8? 3, negative 5. So we could rewrite this as x minus 3 times x minus 5. If we set f of x equal to 0, what values of x make this true? 3 and 5, very good. So there's our two values of x. Here is a very quick but still pretty darn good visualization of it. There's the point 3, 0. There's the point 5, 0. And this quadratic goes down and up this way and up that way. It happens to have a y-intercept way up there at the point 0, 15 and has roots of 3, 0, 5, 0. Now you can take a look at these 3 points, 0, 15. That makes sense. When x is 0, all of these are 0, so the quadratic is just equal to that. You can also test that there. Negative 3 times negative 5 is indeed plus 15, so that's the y-intercept. And then the x-intercept is when x is 3, the value of the function is 0. When x is 5, the value of the function is 0. And you can bet if we completed the square, we'd find 4 minus 1. Right in between those 2 points as the vertex. So all of that is just falling out of your algebra for you so that you can create really accurate sketches and understand quadratics thoroughly. However, this one that we looked at in the warm-up, we completed the square and we found that it looked like this, right? F of x equals x minus 2.5 squared minus 7.25. Wow, that's a little bit freaky, but not that bad. And it's over there. This is the point negative 2.5, 7.25, but negative. Okay. And, sorry, not negative 2.5, my goodness, that is positive. I put it in the right place, but I still labeled it as negative, because that one is sign flipper. Okay. And then it goes up, its y-intercept is there at 1, and it clearly has a root there. And it clearly has a root somewhere there. Okay, it's got these two roots. But there's no way we can win this x game. We can't multiply to minus 1 and add to minus 5 with integers. We can do it with real numbers. Numbers in between the integers. Yes, that's right, Wilson, between the integers. So, how are we going to find it? Oh my gosh. Well, there is a formula that will do it. It's with the form ax squared plus bx plus c. You can even use this form, this special equation, instead of factoring. I can teach, if you hate factoring, I put you through the valley of the shadow of factoring, and some of you emerged feeling very proud of your factoring abilities, and I'm proud too, and others emerged saying, this is still really hard. I'm glad I developed some algebra skills, but it's still really hard. I'd prefer to just have a mechanical way I can just do it every time. And I've met people who are high-level mathematicians who are like, I never factor, I just use the quadratic formula. And that's fine. So, the solutions to this quadratic equation, notice, it is set to 0. It's very important that we have a ax squared plus bx plus c, and it's set to 0. If you're asked to find the zeros of a vertex form quadratic, you can expand it to standard form and then solve it with quadratic formula. That's another way, okay? So, someone tell me what the formula is. It's x equals negative b. Keep going. Plus or minus the square root. You keep on dropping. b squared minus 4ac over 2a. Okay? Turn it into a little melody that's going to stay with you for the rest of your life, because I promise you the quadratic formula is not going to change. It's going to stay same. This is really useful. The reason this is like a thing that I have to teach you and we have to take a day for is there ain't no way to isolate x here, okay? Well, there is, and it looks like exactly this, okay? Because x is in two places in that equation, it's squared in one place and not squared in another. I can't just move stuff to the other side and say x equals blah, 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 like I can with an mx plus b, like I can in a linear situation. This is quadratic, and it got way more complicated. So this is the way we isolate it. X is now isolated, and it's now this function of a, b, and c. And rather than have to compute that every time and do your algebraic manipulations, we can just dump everything into the quadratic formula. But unfortunately, one of our students is not here who told me that this formula is their op and feels that it's like out to get them or something. But I'm here to show you strategies so that you can avoid common errors. Okay, there's so many places where students will make so many errors here that are avoidable if you just do things the way I say. And so this is what I say you do. Okay, make a chart with a, b, and c. All right, so we're going to do this with x squared minus 5x minus 1. Okay, there's our quadratic that we're going to solve. Make a little chart. Here's what our chart would look like. A equals, B equals, C equals. Do this off to the side so that you can clearly see, okay, my A is this, my B is that, my C is that. What's my A? 1. What's my B? What's my C? Good. Write this chart down. Don't skip this step. You can make errors by substituting incorrectly. So make it hard to make errors rather than hard to get the answer right. Okay? Next, copy the whole formula, please, and sing it each time. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. Oh, that's fantastic. It's beautiful. We need to work on our harmonies, but we've got the rhythm down. Okay, next, substitute into brackets. Is that the 87th or the 89th time I've said that? I'm losing count. But always substitute into brackets. All right, so now we're going to substitute into brackets. X equals negative 5. See what I did? Negative 5. I put the b value into brackets because negative 5, hands up if that's confusing. Yeah, it's confusing to me too, but I put it into brackets and then I remember. Negative of a negative is a positive. So I see it in my work and I'm not making the error just putting negative 5 there. Oh, I thought it was negative. It is, but it's a double negative. It's not positive. Okay? Right, positive 5? If you feel confident with that, do it. I would do that, but I'll see students make errors here. So that's why I suggest, like, this is the foolproof way. Okay? I would do the whole thing in my head, Jude. But some students will make errors, okay? All right, so anyway, so plus or minus the square root of, put it in brackets again, b squared. Negative 5 in brackets squared, is it positive 25 or negative 25? Tell me now, I need to know. This is positive 25. Good. It's going to be positive every time because we're squaring the whole value of b. That includes the sign. You see it clearly when you substitute into brackets. Minus 4 times, put it in brackets, 1. That's a. Put it in brackets c, minus 1. All over 2 times a. Okay? I'm being extremely formal here. Hey, tell your neighbor to improve his posture so that he stays alert through the lesson. Yeah. Yeah, good. Okay, so here, then we've got x is equal to, now to be honest, I might not actually write down my a when it's 1. Okay? I might skip those steps. But I encourage you for today, your hand will not fall off if you do a little bit of extra writing, and you will like seeing all the numbers kind of coalesce into these two beautiful roots. You'll like it, I almost promise. Okay, so now I evaluate. Now we evaluate in Bedmus order. The whole square rooty thing is like a set of brackets. All that needs to be, there's invisible brackets there that surround everything underneath the square root sign. Okay? So you could even draw those for yourself with a pair of square brackets if you like. It would not change it, but it would make it very clear to you that all that needs to be evaluated, and then you take the square root. Okay? And then anything that's like separated by addition or subtraction, we can kind of organize as well. So negative 5. Here, Jude, I would write 5, no problem. I'm going to simplify that. Plus or minus, I have to keep that. And I'm also connecting the plus or minus idea to, oh yeah, it's a quadratic. We're going to have two answers. They're going to be separated by the square root of b squared minus 4ac over 2a. Okay. And then negative 5 squared, we're going to do that, 25 minus 4 times 1 times minus 1. What have we got there?
4.
4 times 1 times minus 1, though. But then times minus 4?
Yeah.
Yeah, it's positive 4 here. Yeah, we're going to be adding 4 at the end of the day. Negative 4 times 1 times negative 1 is plus 4. So that's a good simplification. Or we might have minus 4, and that would be okay too. But if you subtract 4 here and end up with 21, you are incorrect. We need 29 underneath those that square rooty thing. And then 2 times 1 is just 2. Okay? Then we have our final answer of x is equal to 5 plus root 29 over 2, or 5 minus root 29 over 2. And these we could punch into a calculator, and these would tell us the answer. Okay? So, square root of 29. How can you estimate its size? Okay, I'm going to create a little number statement, and you tell me if it's true, okay? Is this true? Is 29 at one time, is it bigger than 25, but also smaller than 36? I think that's true, right? So what about this? This would also be true. Square root 25 is less than square root 29 is less than square root 36. How can I simplify this whole thing? 5 is less than root 29, which is less than 6. So now I know that the square root of 29 is somewhere in between 5 and 6. It's going to be an irrational number with all kinds of decimal places going off to infinity with no pattern in them. It's not like 1/3 where it's just a bunch of 3's for infinity. This is, 5, 7, 2, 3, 8, 3, 5, 7, 7, 9, blah, 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 right? But we know it's between 5 and 6. So when we have 5 minus that, we're going to be ever so slightly negative. Do you agree? But less negative than negative 1. And if we have 5 plus that, this is a little bit bigger than 10 on 2. So I already know that my x is about 10 point something. Let's just say 10.2 for now. I think it's about that. Or about 0.2 but negative. Okay? And then if we take a look at our sketch, there's our value, like somewhere around 5. This was incorrect. This is like I was thinking about that. It was like about 5 because we have to divide by 2, right? So 5 plus about 5 divided by 2 is about 5. 5.1, let's say. And then this one maybe negative 0.1. So there's our roots. This is like 5 point something. We'll say 5.1 for now, but then we'll check on a calculator. And this is like minus 0.1. 0. Misspeaking a lot today. Sorry about that. So there's our roots. We would never find them by factoring because it's a weird irrational number and it's really hard to find that. But you will find they do add together to make exactly 5. Sorry, make minus 5. When we flip the signs. And they multiply together to make minus 1. They do satisfy this x game. We would just never find them playing x game. That's why we can't solve it by factoring. Okay, so now let's go ahead, and this is how you punch it in a calculator. This is important. So we're going to just get a little calculator lesson here. We've got 5 plus 29, but I take 29 square root. There it is, 5.38. So we're going to have about 5.2. And so that's equal to 10.538. I divide that by 2, and I get 5.19. So we're closer to 5.2 than 5.1, my guess. But I'm still really happy with that guess. It shows me about where it's landing on the x-axis. If I want really accurate, that's super accurate. And then for the other one, I do 5 minus 29, but I take its square root, equals this negative number. I divide it by 2, and then I have negative 0.2. There they are. There are the roots. So the solutions to quadratic equations are usually irrational numbers. And we've been looking at ones that are factorable. We created factorable ones with cards. If we did random quadratic equations, chances are we'd need the quadratic formula to factor them and solve them and find their roots. That's fine. That's why we got the quadratic formulas. So now I'll give you a little bit of time. Maybe try this one first, and then try that one next and solve them. Actually, this one is actually easier. Solve this one first and that one second. We'll pause the video and then come back in just a moment. All right, you've had a bit of time, so walk me through. Step 1, I make my little chart. A equals B equals C equals. What are they, everybody? What's my A? 2. What's my B? -9. What's my C? 1. And then I sing it. X equals. Let's go. Negative B plus or minus the square root of B squared minus 4AC over 2A. And then we go ahead and we say X equals, substitute into brackets please, minus 9. My hand didn't fall off writing the extra bits. Plus or minus the square root of -9, in brackets please, squared, minus 4 times A, which is not A, it's now 2. I was about to write A because I'm kind of singing. 2 times 1. Maybe I don't write that 1, but who cares? I just write it down. All right, because multiplying by 1 don't change nothing. Over 2 times 2. And then evaluate. X equals 9, positive, plus or minus the square root of 81 minus 8 over 4. X equals 9 plus or minus 73 square root over 4. And then I quickly, you don't have to do this, but I quickly estimate the value of root 73. What two integers is root 73 in between?
8.5.
It's about 8.5. That's really good. Yeah. So let's see how good Mr. G's guess is here. 73, but I take its square root. 8.54. What a great guess. So there you go. It's almost smack dab in the middle between 64 and 81. Because it's in between those two numbers, it's going to be between 8 and 9. So great job. So then we can evaluate them. You can leave it like this. That is the exact value, and that is useful as an answer in math. If it was physics class, you better give a decimal approximation, so we better evaluate it. 9 plus 73, but I take its square root, equals this, divide by 2, equals 8.77. So we're going to go 8.8. Equals 8.8. And another thing I'm going to point out, I am following Bedmus by using the equal sign on my calculator. There's invisible brackets around the numerator. We have to evaluate the numerator before we divide by the denominator. So we have 9 minus 73, but I take 73 square root. I push equals, that's my numerator. I divide it by 4, and I get 0.11. And we're just going to call that 0.1. We're going to round to the nearest tenth for this one. Okay? I will generally give you instructions to round to the nearest tenth, the nearest hundredth. Maybe I'll even say 3 decimal places so people don't get confused when I say round to the nearest thousandth. But please round correctly. Okay, this one, A equals 1, B equals -6, and C equals -27. You can try that one yourself. It's a good one. Let's look at this one. What's different here? Yeah, is that okay? Can we just dump this into the quadratic formula anyway? I see 3 numbers. How about I just throw them into the quadratic formula? Is that all right? Someone tell me it's not all right. That's not okay, Mr. Jennings. That's not okay. You can't just dump this into the quadratic formula. It's not set to 0. So we have 2 choices of how we set it to 0. I could do this in one move. Subtract 5 from both sides and get this equation. Minus 3x squared minus 8x minus 5 equals 0. Are people thrilled that we have 3 negative coefficients? Not particularly, I bet. Are we more prone to errors when all of our coefficients are negative or if they were positive? Negative is going to produce more errors. So how about this? Here, I'm just going to rewrite it again. 3x squared minus 8x equals 5. Instead of subtracting 5 from both sides, what could I do to get positive coefficients? Go to the other side. Yeah, we're going to add 3x squared to both sides and add 8x to both sides. And then we're going to get 0 is equal to 3x squared plus 8x plus 5. Oh, I feel just so relieved that we have positive coefficients now. That's going to be much better. And what else to say about it? Wait, but Mr. Jennings, aren't those two things different? Because one of them's negative and one of them's positive. They are different. But there's something the same about them. The roots are the same. So here's a visualization, okay? I'm just going to quickly visualize these quadratics. Here is, this one has a y-intercept at 5, and it looks like this, okay? Like that, all right? And this one has, I'm going to do this in orange. This one has a thing down here, and it's a quadratic that opens downwards, and it's sloping down. It looks like this. Notice the 2 points that they're going to share. Okay? Do you believe me that that's how they look on the graph? Do you see that the roots are the same? Okay, throw it into Desmos on your phones to verify my visualization, but you're going to find that they share the same roots. Because the same values of x make these things 0. Okay? Because 0 is kind of ambivalent about negative, positive. 0 don't care. Negative 5 times 0 is the same thing as 5 times 0. Okay. All right. So we're going to work with this one. We've got A equals 3, B equals 8, and C equals 5. This visualization predicts that I'm going to have 2 roots that are negative, both of them negative, okay? And maybe a little bit away from 0. So let's see. So now I'm going to go ahead. Yeah, good. So I'm going to go ahead and substitute in the quadratic formula. We're going to have x equals negative b plus or minus the square root of b squared minus 4ac over 2a. That's the Dance Club remix. All right, so then we go x equals negative 8. Oh, Mr. Jennings, you said substitute into brackets. Okay, okay, sometimes I skip it, okay? When here I know negative bracket 8 is the same thing as negative 8, okay? Plus or minus the square root of 8 squared. Yes, again, brackets don't change nothing. Minus 4. Here brackets matter. 3, 5, over 2 times 3. X equals negative 8 plus or minus the square root of 64 minus 4 times 3 times 5 is 60. Cool. All over 6. Oh my gosh. X equals negative 8 plus or minus the square root of 4 over 6. Tell me, what integers is the square root of 4 in between? No. Square root of 4. Just 2. Just good old 2. Oh, what did we just find? Well, our roots are x is equal to negative 8 plus 2 over 6, or negative 8 minus 2 over 6. These equal x equals negative 6 over 6, which is a fancy way of saying negative 1, or negative 10 on 6, which is a sorry, that looks like 16. That's a 10. 10 on 6, which is a fancy way of saying negative 5/3. Here's our roots. They're not weird square rooty irrational numbers. That shows us we could have factored this one. But we didn't. We chose quadratic formula. And that's fine. Just get the answers. There's the answers. And so, here's our roots. -1 and negative 5/3. And if we look at this one carefully, we'll see that yes, we can indeed multiply to 15 and add to 8. We can multiply to 15 and add to 8. It's 5 and 3. And then we do decomposition and we find that the roots are -1 and negative 5/3. Cool. Okay, try these questions. Get some practice. TTFN.
I know this for 12.
And thanks for showing up for your math learning.